Another really useful way of summarizing our information is to use a Venn diagram or a Karnaugh map. And you can use these interchangeably. So you might need to use it, first of all, to determine how many people there are in each of the sections of your Venn diagram. So we know that there's 120 all up, and 15 play neither, so neither would be out here. And we know that that means there's 115 who play either softball or netball. So if we have 75 playing netball and 50 playing softball, that gives us a total of 125, but we only had 105 to choose from. So that means there must have been 20 who played both, which means out of the 50 who played softball, if 20 play netball as well, there's only 30 who play softball only. And out of the 75 who played netball, there must be 55 who didn't play softball. So now that we've got that information organised in our Venn diagram, you just do a quick check to make sure that you have got 120 students. So, yep, I've just done that, and so that's all good. And now if you want to find the probability, so a probability that they play netball and softball, playing both is actually the intersection. Netball intersecting with softball. So that's 20 students out of the total, which simplifies to 1 in 6. Playing neither, so playing neither we have, well, that's the probability. You could write that as the probability of the union complement. So not playing either. So we know that that's 15 out of 120, and that would give us 3 out of 24. So that simplifies further to 1 in 8. And finally, softball but not netball. So softball but not netball is probability of softball intersecting with not netball, and that would be 30 out of 120, which is 1 in 4. It's really important to be able to use both a Venn diagram and a Karnaugh map. So just make sure that you know where they correspond. So for example, I like to use a bit of colour. So the overlap is this first cell here. And when we're talking about S but not in N, S but not in N, and we have N but not in S, so N but not in S, and then finally whatever is outside, so all this bit out here is that cell there. So make sure that you can use either a Venn diagram or a Karnaugh map. They're both useful in different situations. And finally, we're more interested in filling these in using probabilities rather than actual numbers. So you also need to be able to convert them to probabilities. So earlier we found that the probability of neither was 1 in 8. So that's the outside bit. Remember, that goes in this cell here. And we also found that the overlap, or the probability of playing softball and netball, was 1 in 6, and that was that top cell there. And we found the probability of playing set softball but not netball, so that was just down here. So now that we've got those 3 pieces of information, we can quickly and easily fill in the remaining cells. Remember, the probability must total 1, so that bottom right-hand cell always has a 1 in it. So just doing some fraction work, we have 5 in 12 down here, and 5 in 12 plus something has to equal 1, so that must be 7 in 12. And we know that these two here add to 3 and 8, so this must be 5 in 8 there, and then doing some nifty fraction work, we end up with 11 in 24 in that cell, which can be transcribed over here into this one. So netball but not softball is 11 on 24. And if you put that into your calculator, these 4 fractions should all equal 1. So there you go. They all do add to 1, so we can be confident that it's all okay.